Good day, viewers. Welcome to today's class. And today we'll be looking at likely NABTEB physics questions. So these are the questions you might likely see in your upcoming NABTEB exam. Don't forget to go to our channel for more videos just like this. Okay, let's dive right into it. Question number 1 says, a projectile is launched at 30 degrees to the horizontal with initial velocity 20 meters per second. So we are given the angle as 30 degrees. And then we're given the initial velocity u as 20 meters per second. What is the maximum height reached? The maximum height reached we do not know. But we're given g to be equals to 10 meters per second squared. And we know that for projectile motion, our maximum height is equals to u squared sine squared theta over 2g. This is the formula. So with this formula, we're going to find out the maximum height reached by this projectile. So this means that my h is equal to, my u there is 20, so this is squared, times sine squared 30 degrees divided by 2 times 10. So this will give me 400 times, this will give me sine 30 is 0.5 times 0.5 divided by 20. So this 20 here will cut this and I'll get 20. So I'll get, this will give me 20 times 0.5 times 0.5 will give me 0.25, which is the same as thing that I have. This will give me 20 times 1 over 4. So if I divide 20 by 4, that will give me 5 meters. It means that the maximum height reached by this projectile is 5 meters. So that takes us to question number 2, which says the centripetal force F experienced by an object of mass m moving with velocity v in a circle of radius r is expressed as. So what they're simply asking you in this question is, what is the formula for calculating the centripetal force in a circular motion? So we know that for circular motion, our centripetal force F is equals to mv squared over r. So this is the formula for calculating the centripetal force in a circular motion. So in circular motion, it simply means that our formula is supposed to be what? Mv squared over r. So we look for the option that has to do with what? Mv squared over r, and that is what? Option C. So that takes us to question number 3, which says a mass of 30 grams is hung at the 20 centimeter mark. So here we have to draw the diagram, because this question here, from the question you can tell that this is talking about what? Equilibrium of forces. So looking at this, it said I have a mass of 30 grams is hung at the 20 centimeter mark of a uniform meter rule. So this is my uniform meter rule, and my mass was hung at the 20 centimeter mark. So this point here is 20, and the mass is 30 grams. Okay, of a uniform meter rule pivoted at the 40 centimeter mark. So the pivot is at the 40 centimeter mark. This point here is 40. Then the question is, calculate the weight of the meter rule. The weight of the meter rule should be at the center of gravity of the meter rule. The weight of any uniform object is at the center of gravity. So this is the weight of the meter rule. Let's call it W. So it's at the center of gravity. The center of gravity is the point where that particular meter rule can be divided into 2 equal halves. So the center of gravity here, since the meter rule is a uniform meter rule is about 100 centimeters. So the center of gravity of a uniform meter rule is the 50 centimeter mark. So here is supposed to be 50. So if from here, if here is 40 and here is 50, it means that from here down to this place is what? 10. And if here is 40 and this point here is 20, it means that from here down to this place here is what? 20. So we are going to take our moment to the pivot. Taking our moment to the pivot according to the principle of moment. So according to the principle of moment, we are going to tell them that we know that anti-clockwise moment must be equals to clockwise moment. So this means that I have, now ordinarily we would have converted our mass here, which is in gram, to whether a force which will be in Newton or in kilogram, depending on the question. But looking at the weight here that we're given, the weight was given in grams, so we are going to leave it in grams, so there's no need for any conversion. So here we're just going to say this will give me 30 times the distance between the mass and the pivot, which is 20, is equal to my clockwise moment. I have the weight times 10. So this will give me, I'll divide both sides by 10, divided by 10. This means that my weight is going to give me 60 grams. So this means that this particular meter weighs what? 60 grams. And that is what? Option D. This is question number 4, which is calculate the resultant of two forces, 8 Newton and 15 Newton, acting at 60 degrees to each other. So this question is based on vector. So we are trying to resolve this vector. So I have the first vector, which is the first force here. Let's call it P, and it is 8 Newton. And I have another vector. Let's call this Q, and it is 15 Newton. And they said the distance, the angle between them is 60 degrees. So we're trying to resolve these two vectors. So if you want to resolve these two vectors, we are simply going to use this formula that says R, which is the resultant, is equals to square root of P squared plus Q squared plus 2PQ cos theta. So with this, we are going to use this formula to solve the question. So this means that my R will be equals to square root of 8 squared plus 15 squared plus 2 times 8 times 15 times cos 60. So I have, so that will give me square root of 64 plus 225 plus 240 times 1 over 2, because cos 60 is 1 over 2. So this will cancel this, and I'll have 120. So that's the same thing as saying I have 64 plus 225 plus 120. So that will give me square root of 409. So if I find the square root of 409, that will give me 20.2 Newton. So it means at the end of the day, my answer to this question is 20.2 Newton, which is option B. So that takes us to the next question, which is question number 5. It says, during an Olympic game, a sprinter made one lap around a 400 meters track in 30 seconds. Find the average velocity. Now, whenever there is movement in a loop, what do we call a loop? If a body starts moving from this point in a circle, and moves around the circle and comes back to this point, the average velocity of that body is 0. Why? Because that body has moved from its starting point and has returned back to its starting point. So it is assumed that the body did not even move, because the body has returned back to its original starting point. That means there is no average velocity. It means that the average velocity of this body is 0. Likewise, when this Olympic sprinter decides to run around the 400 meters track and comes back to its original starting point, it means that that particular sprinter has 0 average velocity. So the correct answer to this question is option B, which is 0.0 meter per second as the average velocity. So that takes us to the next question, which is question number 6. It says, a body of mass 5 kg is projected vertically upward with velocity 20 meters per second. So we have the mass of the body to be 5 kg, and we said it is projected vertically upward with a velocity u to be 20 meters per second. The question is, what is the time to reach maximum height? What is the time to reach maximum height? We do not know. And we're given g to be equals to 10 meters per second squared. Now we know that The time it takes for a body to reach maximum height is equals to the velocity of the body over the acceleration due to gravity. The velocity of the body over the acceleration due to gravity. And if what I have here, if my t is equal to u over g, this is the same thing as saying that my t is equal to 20 divided by 10, and that will give me 2 seconds. Please note that the mass is not needed to find the time it will take the body to reach maximum height. So it means that the answer to this particular question is 2 seconds, which is option B. So that takes us to question number 7, which is the pressure of a gas supports 0.7 millimeters of mercury. So we have the height of the mercury here as 0.7 millimeters. 0.7 meters. Sorry. Then they said the relative density. The relative density here is the density of mercury over the density of water. They said their relative density is 13.3. And then they said, what is the height of water column? What height of the water column will support it? So will it support? So here we are trying to find the height of the water column. The height of H2O is unknown. And we know that G is a constant, which is 10 meters per second squared. But we know that pressure is equals to H real G, or you can simply say real Hg. Real Hg. And what does this mean? This means that the density times the height times the acceleration to gravity will give you the pressure of a body. So this is the same thing as saying, therefore, that the pressure that is here is, so since we are going to try to support this particular pressure of the gas here, so this means that the pressure in the mercury must be equal to the pressure in the water. So with this, we know that the density of mercury, here I have the density of the mercury times the height of the mercury times G is equals to the density of water times the height of water times G. So since G is common, G will cancel out itself. This means that I will be having, so since I'm looking for the height of the water, I'll simply tell them, therefore, that the height of the water, H2O, will be equals to the density of the mercury times the height of the mercury divided by the density of water. But I know that the density of mercury over the density of water is equal to the relative density, which is 13.3. So this is the same thing as saying, therefore, that the height of the H2O will be equals to the relative density, which is that of mercury over that of water, times the height of the mercury. So this will give me 13.3 times the height of the mercury that was given was 0.7. So I have 13.3 times 0.7, and that will give me 9.31. So looking at this, it means therefore that the height of water column that would support it is 9.31 meters, which is option C. This is question number 8, which says a simple harmonic oscillator has amplitude 0.1 meters. So we are given the amplitude as 0.1 meters and a frequency. So we are given the frequency as 2 Hz. 2 Hz. What is its maximum acceleration? Maximum acceleration, a mass, is unknown. So for us to solve this question, we first have to know what the angular velocity is. And our angular velocity, omega, is unknown, but we know that omega is equals to 2 pi f. So since we know that omega is equal to 2 pi f, this is the same as saying that my omega is equals to 2 pi times 2, which will give me 4 pi. 4 pi rad per second. So since this is what I have as my omega, I know that my maximum acceleration is equals to omega square a. Omega square a. So this is the same as saying that I have 4 pi square times 4 pi square times, so this will give me 0.1. So 4 pi square times 0.1, because my acceleration, my amplitude there is what? 0.1. So this means that my maximum acceleration here is going to give me 16 pi square times 0.1, which will give me 1.6 pi square meter per second. So looking at our options here, we're going to look for what? 1.6 pi square meter per second. So looking at our options, you know that this is what? Option D, which is what? 1.6 pi square meter per second. If you have been enjoying this video down to this moment, this is the point where you subscribe and you go to the channel for more videos just like this. So don't forget to check out our channels for more videos just like this. So let's continue with the question. Moving on to question number 9. Determine the acceleration from a velocity time graph where the velocity changes from 0 to 40 meter per second in 8 seconds. So we have the initial velocity here as 0 and the final velocity v here as 40 meter per second. And they told us that it does this change in 4 seconds. It means that my change in time here was 8 seconds as it is given in the question. So, and we know that our acceleration is change in velocity over change in time. So this means that my acceleration here is v minus u over change in t. So this means that my acceleration therefore is 40 minus 0 divided by 8. And that would mean that I have my acceleration to be equals to 5 meter per second square. So the acceleration in this question is 5 meter per second square, which is option C. So that is the next question, which is question number 10. It says a satellite in circular orbit has period T and radius r. The gravitational force is, so our gravitational force was given as gmm over r squared. And we know that this is in a circular orbit, and so means that my force is also equals to my centripetal force, which is mv squared over r. So if I equate both of them, it means my mv squared over r is equals to gm m over r squared. So if I divide both sides by m over r divided by m over r, this is also divided by m over r. So it means that my v squared will be equals to gm over r. So this means that my v is equals to square root of gm over r. So, but we know that our period is equals to 2 pi r over v. So if I impute my values, it means that my period is equals to 2 pi r over square root of gm over r. So this is simply, if we simplify further, this is the same as saying I have 2 pi divided by square root of gm over r. So this can also mean that I have my t to be equals to 2 pi r here. Then I have times R square root of R over GM. So this can be simplified for that to mean that I have my this is equals to 2 pi square root of R raised to power 3 over GM. Now you might be wondering how I got R raised to power 3. This R square here is simply saying, okay, let me simplify that and show you how I got my R raised to power 3 there. So this is the same thing as saying that T is equals to 2 pi times my R here simply shows that I have was square root of R squared. This is times square root of R over square root of GM. So square root of R squared here will give me R, which is what I have here. So this is the same as saying that my T is equals to 2 pi square root of. So I have R squared here and I have R squared here, which will give me what? R cubed over GM. So this will become our what? Formula for calculating the period of this particular satellite that is what rotating in the orbit. So looking at our options here, so we're looking for 2 pi square root of R cubed over GM. So that will give me option B. So the correct answer to this question is option B. So that takes us to the next question, which says the density of water is highest at dash. Now we know that whenever water is heated between 0 degrees Celsius and 4 degrees Celsius, that particular water or that quantity of water contracts. And whenever a particular substance, whenever a fluid or a liquid contracts, it means it becomes denser. So between 0 and 4 degrees, at 4 degrees Celsius, water is the most dense form it can ever be. So it is denser when it is at what? 4 degrees Celsius. And because it contracts at that 4 degrees Celsius, it means it is what? Denser at 4 degrees Celsius. And when you continue heating it above 4 degrees Celsius, then it becomes what? It starts what? Expanding uniformly instead of what? Contracting. So it means at 4 degrees Celsius, water has the highest density. So the correct answer to this question is option B, which is 4 degrees Celsius. So that takes us to question number 12, which says, which change can alter, or which change or changes can alter the boiling point of water? Roman figure 1 says increasing the volume. Roman figure 2 says increasing external pressure. And Roman figure 3 says adding impurities. Now, when you increase the volume of water, it only changes. The only thing that is going to add or is going to alter is not the boiling point, but the time it takes water to boil. So it is not going to change the boiling point from 100 degrees Celsius to any other boiling point when you increase the volume of the water. So if you continue adding more water, it's going to extend the time it will take the water to boil, but it's not going to change the boiling point. But when you add impurities, it is going to change the boiling point, increase it above 100 degrees Celsius. Likewise, if you increase the external pressure, if the pressure in the atmosphere is higher, it means that your boiling point will also increase. So the only two things that are going to affect or alter the boiling point are the external pressure and the addition of impurities. So the correct answer is one that has to do with Roman figure 2 and Roman figure 3, and that is option C. So correct answer is option C. So that takes us to the next question, which says a gas occupies 200 centimeter cube at 27 degrees Celsius. So we have a gas occupying 200 centimeter cube at 27 degrees Celsius. So the volume was given V1 as 200 centimeter cube, and the temperature T1 was given as 27 degrees Celsius plus 273, which will give me 300 Kelvin. What volume does it occupy at 54 degrees Celsius? So we are given a new temperature T2 as 54 degrees Celsius plus 273. So that will give me 327 Kelvin. And they're asking us what is the volume. We do not know. But we know that V1 over T1 is equals to V2 over T2 according to Charles' law. So if we input our values, I have 200 over 300 is equals to V2 over 327. So this means I have my V2 to be equals to 327 times 2 divided by 3. So I have 327 times 2 divided by 3. It means that my V2 is equals to 218 centimeter cube. It means that at the end of the day, the volume, its volume at 54 degrees Celsius is going to be 218 centimeter cube, which is what? Option B. So the correct answer is option B. So that takes us to the next question, which says, calculate the heat required to raise 2 kg of water from 20 degrees Celsius to 100 degrees Celsius. So I'm trying to raise 2 kg of water from 20 degrees Celsius to 100 degrees Celsius. So the mass of water was given as 2 kg. We are given the first temperature θ1 as 20 degrees Celsius. We are given θ2 as 100 degrees Celsius. We are given the specific capacity of water as 4,200 joules per kilogram per Kelvin. So we have to find the quantity of heat. We do not know. But we know that our quantity of heat is equals to mc θ2 minus θ1. So this means that my quantity of heat is equals to 2 times 4,200 times 100 minus 20, which will give me 2 times 4,200 times 80. So I have 2 times. So that will give me 672,000 joules, which is equivalent to saying I have 672 kilojoules. So my quantity of heat is 672,000 joules or 672 kilojoules, which is what? Option C. So that takes us to the next question, which is question number 15. It says, the relative density of acid in a car battery is measured with a dash. Now, when you want to measure relative density, we use an apparatus called the hydrometer. But when you want to measure relative humidity, we use an apparatus called the hygrometer. Now, these two are very much alike, but do not mistake them. They are very much alike. The only difference is just a letter. We have what is called the hydrometer, and we also have what is called the hygrometer. Now, if you look at this, the only difference between these two is D and G. Hygrometer, which is this, is for measuring relative humidity, while relative density is measured using the word hydrometer. Hydrometer, as in water, hydrometer. Why this is what? Relative humidity. So the correct answer to this question is option A, which is what? Hydrometer. So that is the question number 16. It says, a black body radiates energy at the rate of, so we're given the rates here. So if the temperature doubles, by what factor does radiation increase? So here, remember that the temperature was what? Raised to power 4. So if my temperature is raised to power 4 and temperature is 1, now then I say that the temperature doubles. So when it doubles, so my double temperature, double T is going to give me 2, which is the double, raised to power 4. And 2 raised to power 4 will give me what? 16. It means that if the temperature doubles, the factor by which the radiation will increase will be to what? To the factor of what? 16. So the factor here is going to be what? 16, which is what? Option D. So that takes us to the next question here, which is question number 17. It says, which will reduce surface tension of a liquid? Remember, figure 1 says alcohol, remember, figure 2 says oil, and remember, figure 3 says detergent. Please note that all 3 substances will reduce surface tension, and all 3 will affect the rate at which what a substance is able to remain on top of water or on top of a liquid. So surface tension will reduce when you add any one of these 3. So the correct answer is I, and I, which is what? Option D. So that takes us to the next question, which is question number 18. It says, the latent heat of vaporization of water is 2.26 times 10 raised to power 6. So the latent heat of vaporization of water was given. So we have the latent heat L to be 2.26 times 10 raised to the power 6 joules per kilogram. And we're given that what is the energy required to evaporate? We're given the mass as 0.5 kg and the temperature as 100 degrees Celsius. But please note that anytime we're talking about latent heat, temperature is not required for the calculation, because latent heat is the quantity of heat required to change the state of a substance without a change in temperature. So this means that my quantity of heat is equals to what? ml, because in the question they said the energy to evaporate 0.5 kg is dash. So the energy is unknown, which is what? Quantity of heat. So my quantity of heat here is going to be 0.5 times 2.26 times 10 raised to the power 6, which will give me 2.26. So that will give me 1.13 times 10 raised to the power 6. So the correct answer to this question is 1.13 times 10 raised to the power 6 joules, which is what? Option A. So that takes us to the next question, which is question number 19. It says, a graduated cylinder filled with water at 40.3 centimeter cube rises to 63 centimeter cube. So here, so I have the cylinder filled with water at 40 to up to 40 centimeter cube, and then when they added copper, it increased to 63. It means that the volume of copper that was added, is going to be 63 minus 40.3, and that will give me, so that will give me 22.7 centimeter cube. That is the what? Volume of copper that was added. And I said if copper mass is, so if the mass of the copper that was added is 178 gram, what is the density? So we're looking for the density, we do not know, but we know that density is equals to mass over volume. So this means that I have 178 gram over, so now why am I not converting this to be in kilogram? Because I know that my density is supposed to be what? Kilogram per meter cube. But if you look at our options, they are all in gram per centimeter cube, so I'm not converting any one of this. So this will give me what? 178 over my volume here is 22.7. So I have 178 divided by 22.7. So that will give me 7.8 gram per centimeter cube. So our correct answer here is 7.8 gram per centimeter cube, which is option A. So that takes us to the next question, which is question number 20. It says, in a thermodynamic process, work done is 500 joules. So in a thermodynamic process, so I have a thermodynamic process, and then it said the work done is 500 joules. So our work done was given as 500 joules. And then it said heat added is 800 joules. So our heat that was added, or our quantity of heat that was added, is 800 joules. Then it said the change in internal energy is dash. So the change in internal energy is dash. And we know that our change in internal energy is equal to the heat added minus the work done, which means that my change in internal energy is going to be 800 minus 500, which will give me 300 joules. It means that the change in internal energy of this thermodynamic process is 300 joules, which is option A. So that takes us to the next question, which is question number 21. It says, a sound wave has frequency. So we have the frequency of the sound wave. A sound wave has frequency. So we are given the frequency of the sound wave. Frequency of the sound wave, F, as 512 Hz. And wavelength, lambda, as 0.66 meters. The speed of sound is unknown. And we know that the speed of sound is equal to F lambda. So this means that my V is equals to 512 times 0.66. So I have 512 times 0.66. So that will give me 337.9 meter per second. So we have 337.92. So, okay, since they put all the values, so we have 92 meter per second. So looking at our options there, that is what option A. That is the next question, which is question number 22. It says, in Young's double slit experiment, fringe width is 0.5 millimeters. So we have the fringe width given as 0.5 millimeters. And then we're given the slit as 0.2 millimeters. And we're given the screen or the deviation as 2 meters. So you have to convert this to meters. So this is 0.2 times 10 raised to the power minus 3. This is 0.5 times 10 raised to the power minus 3, which is the same thing as saying that I have 5 times 10 raised to the power minus 4 meters. This will give me 2 times 10 raised to the power minus 4 meters. And we have to find the what? The wavelength. And we know that, so this is fringe width. So we know that the fringe width is equals to lambda d deviation over d. So here we are trying to find what? The wavelength. So this means that my wavelength is equals to bd over d. So this will give me that my wavelength lambda is equal to 5 times 10 raised to the power minus 4 times d here is 2 times 10 raised to the power minus 4 divided by 2. So this will give me, so I'll have 5 times 10 raised to the power minus 8. So it means that the wavelength here is 5 times 10 raised to the power minus 8 meters, which is what? Option C. So we've come to the end of today's class. Don't forget to go to this channel for more videos just like this.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams, including JAMB, WAEC, Kakao,